Okay, so how do we use potential energy and kinetic energy with electrical forces? So suppose we have an electron that's just sitting there, but there's another electron that is being moved by the first one, and it's traveled from 1 meter away to 2 meters away, and we want to know how fast would that have accelerated to. And so we're going to assume that originally they were sitting 1 meter away and they were both just with no velocity, but the second one moved away, was being pushed away by the electrical force, and then 2 meters away we clock it and see how fast it's going. So just like back in physics 1, in the beginning there's a certain potential energy and kinetic energy in the very beginning, and then in the end we have a kinetic energy final plus potential energy final. Okay, now one thing we could do right away is destroy the kinetic energy initially. The reason for that is initially we're assuming that the electron has no velocity, so it can't have kinetic energy. And then we're going to fill in potential energy initially. So this is going to be K, and then that's going to be, in this case, K little q squared, because the charges are going to be the same all over a distance of 1 meter away. Now the kinetic energy finally is going to be 1/2 mv squared, and the potential energy in the beginning is kq squared, in the end is going to be kq squared again, but the distance has changed to 2. So we fill in what we know, and then one thing you can realize here is that these are like terms, so I'm going to subtract this to that side. So if I subtract that over, I have 1 kq squared, and I have 1/2 kq squared, so that's going to be 1/2 kq squared. The nice thing about this is there's a half on both sides, so those cancel, and I'm trying to find velocity, so I'm going to divide by m and square root both sides. Now what's left here to do is to plug in the actual numbers. So k is 8.99 times 10 to the 9th. The charge of an electron is negative 1.6 times 10 to the negative 19th, and then that leaves us with the mass of an electron. The mass of an electron is 9.11 times 10 to the negative 31. And in the end, we're going to square root this. Also, we need to make sure that we're squaring this. I almost forgot. Alright, so in the end here, we're calculating a velocity of 15.89-ish meters per second. So that's approximately about 16 meters per second. Times 9 divided by 4 to get a good estimate of the miles per hour. 16 times 9 divided by 4, that's going to be about 36 miles per hour, 40 miles per hour. Okay, so that's after 1 meter of acceleration. That's how fast your electron would be.